This time we talk about platform. If you're a CPP developer, you might experience a scenario where you find one function needs to be implemented differently between one operating system and another. Most likely, you know that the macros predefined in the compilers can help you achieve the code variation. But the limitation of this way is quite obvious. All of the variant code exists in one source file, and the macros can be a distracting factor for the code reviewer. More than that, if you wanted to distinguish the code with different tags, for example here you see the simulation platform and the target hardware platform, those macros need to be declared. To solve the code selection problem, Bazel provides platform and constraint terminology and concepts. The constraint setting and constraint value are Bazel built-in rules. The constraint setting target is similar to the enum class in the C++, where you define a category of a constraint, for example, the operating system and the CPU architectures. The constraint value targets are the actual values belonging to a constraint category, just like the enum values. Platform is another Bazel built-in rule. A platform target is a collection of constraint values that represent the characteristics for some environment. Pay attention that the constraint values list does not allow duplication of the constraint settings, which means if you already have OS Linux in part of the constraint value list, you cannot add another constraint value OS, macOS, or OS Windows. Bazel provides an external dependency called platforms from the Bazel Central Registry. It defines a host platform which describes the current CPU type and operating system type where the Bazel is running. Other constraint values like the operating system Linux, macOS, Windows, Android, or iOS, and the CPUs x86, ARM64, or RISC-V are the predefined constraint values from this repo. With some pre-knowledge, we can talk about how to use a platform in Bazel. In the Bazel world, 3 platform categories have been defined. The host platform means where the Bazel itself runs. The execution platform means where the build actions are running. The target platform is where the final output resides and executes. Depending on the equalness of the 3 building, we can categorize a build into 3 categories. In most cases, you care about a single platform builds and cross-compilation builds. That's the most common scenarios in the daily life. If you use remote build, you might meet a condition where all these 3 platforms are different. That is multi-platform build, which will be out the scope of the discussion here. During the build process, Bazel will resolve to the correct target to be compiled by selecting the constraint value passed by the platform argument. The constraint values defined in the build platform target describe the target platform for this build command. If you don't specify this, the host platforms from the external dependency platforms will be used. For every Bazel target, you can use a select function that match the constraint value passed from the platform argument to participate in the build actions. You can also specify the target compatible with field with the constraint values that are required on the target platform for this building target. Let's have a real example for better understanding. I define 3 constraint settings A, B, C, and each of them has a few constraint values. The target to be built selects the CPP files based on A1 or A2, and the platform X is a collection of A1 and C2. When we build the library with platform X, the constraint A1 from the platform X has a match in the select function, so this target can be built. If I specify the target platform to be platform Y, then the build will fail because none of A3, B2, C2 from the platform Y can be found in the select function. However, if I add the condition default in the select functions, then the build from the platform Y will be successful, since the not found constraints in the selection list will fall back to the condition's default. Now we have another build target bar, which selects based on A3 and B2. If we build this target also with platform Y, then the build will fail, because A3 and B2 are found both from the platform Y, but in the select function, A3 and B2 points to different files, then there is a conflict of the resolving process. That's why this build will fail.